Assalamu alaikum, viewers. How are you? This is an integration life class C and A levels. Many other students were insisting to conduct a class of integration. So let us do together, let us learn together the integration processes, integration techniques, and methods. So this is these topics are there. They are actually lifelong topics as far as mathematics is concerned. You come across integration almost everywhere in your life, whether you're a student of mathematics, FSC, A levels, BS, the graduation, or even later. The integration can come across you at any time. So in mathematics and physics, maybe in economics. So integration is almost spread around in all fields. So let us learn today in this live class how to integrate different functions. So this is live class for integration. So let us commit to ourselves that we have to pay attention, not only that for understanding but for uh, practicing it a lot. As much as we can, we will practice using any calculus book, any calculus book. If you pick up, that will have sufficient information, sufficient number of questions, sufficient number of exercises in the drill for you to learn the concept well. So the FSC book has also enough number of questions which can impart you the concept reasonably well. And in A levels, obviously there too, and BS mathematics, if you're doing, then the calculus, Thomas Finney calculus, Howard Anton calculus, Stewart calculus, and a lot more calculus books. One which I'm using, the calculus book, is one that is taught in American uh, high school. So that is another calculus book having an extensive practice exercises and the drills which can enable a student to learn the concept well. To There are many reinforcements already there. So I'm just about to post the thumbnail of this video, that this video is related to integration. So, integration is our today's topic. This is Mathematics channel publishing mathematics content. Nearly 1,000 videos have been published on mathematics, various concepts of mathematics. It's not an advanced mathematics channel. It's the basic mathematics channel, which covers the topics up to grade 10, grade 11, grade 12. So up to high school mathematics, this channel covers the topics related to that. So today our topic is integration. So integration, actually, what integration is, it is a reverse process of differentiation. Anyone who knows differentiation can learn integration relatively easily, or for him, the less effort is required to put. But for the one who don't know the derivatives first, for him it is not easy to grasp the concept, because the information which is being used here is coming from the differentiation. So this is integration for FSC and A levels. Integration for FSC and A levels. So this is going to be a class where you will be learning techniques of integration. So FSC is high school. syllabus or the high school program which is offered in Pakistan, while A levels is Cambridge system in international education, Cambridge Assessment International uh, offers A levels. So both of these programs and the curriculum include the topic of integration. So integration remains a challenge for students. So here is today's class is organized to impart the concepts, techniques, and the basics of integration and a bit sort of a drill reinforcement. So that will enable students to grip the concept and can uh, cruise to the subject from these topics easily. Welcome, students. Welcome, audience. You are here on this channel. This is a channel devoted for mathematics. It publishes mathematics content for years now. Nearly 1,000 videos on various concepts of mathematics have been published. Though the most of them are the short videos, which another concept is used in those, that audio is another, most of the channel you see on online, they play music, background music, and a question is being solved. So I also have used the same technique where the audio is different than the video. Video is mathematics. A question is being solved, and the background voice, background audio is different. So it is kind of a blend of mathematics and some motivational, some spiritual, some these kind of audios. So you can enjoy if you go through, if you watch these shorts which I have published, you will enjoy two things together: the motivation, the the virtue of the human society, human race, and the mathematics. Basically, it is the mathematics, and together with blend, it is blend of mathematics and the spiritual and actually the audio which are selected here are the one which can benefit humanity more, the benefit less the entertainment. So the purpose is actually not to entertain public with the content which can be a little objectionable, but the audio is carefully selected so that it can benefit anyone. It can give a very clear and a beneficial message, the message which can benefit people's life, which can influence people's life positively. So that kind of audio is blend with mathematical content. So if you go through the channel, if you watch some shorts, you may find some uh, audios which will be motivational, which will be the guiding videos for the entire humanity. Guiding audios actually blend with mathematics, so you can. It is that kind of channel. You will definitely appreciate my work if you watch the short videos of this channel, especially. And this channel has been publishing mathematics content for long now. It's been 5 years, though the channel growth is not that much, but the uh, the motivation behind it, the dedication behind it is immense, is unmatched, and with the blessing of Allah Almighty, I can commit myself, I can force myself to keep publishing this content, keep blending the mathematics uh, uh, with the some ethical, moral, informative uh, content, some knowledgeable content. So I used to do that, and this up till now, to the motivation behind and the dedication is yet intact, is not distorted by any life affair. So this has been uh, a, a blessing that I am connected with my subject and publishing and connecting with the audience. And today is the topic we are going through is integration. Thank you for joining. Please hit the like button, hit the subscribe button, and let us proceed to learn integration. The book which I have selected is an American high school book. Is calculus. This calculus taught there. It has immense number of exercises, number of practice questions which I can solve before you in order to uh, tell you the techniques of integration, how a function is integrated. So integration for FSC and A level is the topic today. Thank you so much, audience, for joining. And this channel is going to publish in today's live stream the content related to integration, a very important topic of uh, FSC, the Pakistani program, high school program, FSC, and ICS, and some other groups. And in A levels, which is Cambridge Assessment International program, so they both offer these two programs internationally. One runs in Pakistan, the other runs actually FSC also. Maybe you can call that international because Pakistan embassy schools are in colleges everywhere around the world where the Pakistan embassy is. There are FSC students also, so they FSC schools, colleges, and the curriculum that is taught. So the topics are the basic difference in A levels and the Pakistani system is what I have after being into the field for nearly 2 decades. I can tell you that the difference in these two topics is just the application aspect is less focused in Pakistani curriculum, is more focused in Cambridge Assessment International. So the basic what the Pakistani curriculum development authorities they think that why they keep that application part away from the subject. I don't know. I'm astonished that why have they done this. While on the other hand, Cambridge Assessment International obviously is recognized globally, has those topics more connected with the practical uh, life, the surroundings. What we can see around us is actually is brought into the subject through wording, and from there we handle those situations, those problem solving we do, and the subject, so that we feel connected while studying the syllabus, the curriculum, the Cambridge Assessment curriculum, and its recommended books. We feel connected with the real world, and no one asks that where mathematics is applied because everything is coming from the real life affairs in those books. While on the other hand, in Pakistani books, what happens is that they give you just a mathematical structure. They show you just sine theta, just cos theta, just a quadratic equation, a linear equation, a simultaneous equation, maybe a trigonometric structure, maybe a matrix, maybe a complex number problem. But where does that come from is nowhere told. So that is the big shortcoming of the syllabus, of the curriculum. I think is that after uh, getting into the field and staying there for 2 decades nearly, I can identify this major problem in the Pakistani curriculum. Otherwise, the topics, as far as our today's topic, is integration. So, integration is equally taught there and in Cambridge Assessment International curriculum, but the difference lies again there that the more application is given in this curriculum, while in Cambridge assessment curriculum, more uh, application oriented, more connected with the real life. But and the Pakistani curriculum, it is not much connected. So why not it is the new day for 2026. Why not we decide and we plan as a nation to convert our syllabus, our curriculum, not to convert, to upgrade to the international standards like the Cambridge assessment syllabus is. So this can be a thought which can be propagated, and authorities can be asked to do so. So here is our topic today. Our topic is integration. So let us begin our topic. It's integration. Integration may involve algebraic functions. It may involve algebraic functions, trigonometric functions, quadratic function, rational function, uh, hyperbolic functions, exponential functions. So many functions it can involve, and it cannot only be confined to. It can't be confined only to the uh, single variable function. It can be transformed to multivariable functions also. So how can that all be handled, and how we look into it deeply? Let us proceed in our today's discussion. It is related to integration, and integration is the important topic of Cambridge assessment, A levels, as well as FSC, ICS, and the other programs which are run in Pakistan. And this book, which I have selected and I'll be solving questions from, is an American book, which is American high school book. If you, audience, if you want to look at my YouTube channel, this channel is publishing mathematical content for nearly 5 years now, and the motivation, the dedication behind it is still intact, though the 5 years have passed. So, because of the affection and association with the subject actually matters much, and it forces me to keep doing this work, whether you may say it in ordinary work, but for me it is amazing work which I do, and I love doing this. Today's our topic is integration. So how to few of my audience, which is not much, it's not a big base of the audience which I have, but a smaller base audience I have. But some of the from the audience have asked me to publish content related to integration. So this is integration, the topic we have selected today, and let us begin doing first question here is integration of 10. It is a reverse process of integration is reverse process of differentiation. So anyone who has learned in differentiation before will be able to understand this easily. So audience, thank you so much for joining. Only one like yet I could see, but I expect more likes from you. And please hit the like button, and let us begin our topic today. It is integration of 10x, right? How do we integrate it? Actually, this is 10 function, right? 10 function is the combination of sine and cos. So we break it. It is the requirement of integration that we break it into sine by cos form, right? So then we know that it is here we need to find a relation between these two functions. One is sine, one is the cos. Uh, on the basis of uh, differentiation, we would like to find a relation between these two functions on the basis of differentiation. So The derivative of cos is minus sign. I need minus sign here. So this minus sign will disturb the entire given form. So I will bring two minus sign here. So which will convert the minus, the original form, which will keep the original form intact, means minus minus will be plus again. So initially it was plus, there was no negative sign. We introduced two negative signs, which mean that minus minus plus again. So then we know that the derivative of cos is minus sign. This is function in denominator. Look, we will see that it has one power. Okay, its cos power is 1. So when the function has one power and it is in denominator, and numerator is its derivative, so the rule which is used here, let me mention that rule. I will be mentioning what that rule is. Rule is integration of f prime by f of x. So f of x has a power. It is function in the denominator with one power, right? And numerator is derivative. So natural log of function is the integration. Okay, so here we will have, we know that what is in denominator. What is in denominator? We can see in denominator, what is it? Denominator, the function with one power, cos with one power. Okay, cos is with one power. Numerator is minus sign, it's derivative. So when the function in denominator with one power, numerator is derivative, then natural log of the function, natural log of function is cos x. So plus c, this will be the integration. Please hit the like button, subscribe the channel for more mathematical content. You will find this channel publishing great mathematical content blend with some ethical moral audios in its short format, and long format purely mathematical content. So here we can transform it in the form natural log of cos x. We know that the power, the coefficient becomes the power. It is the property of the logarithm. So logarithm converts base into the power. So this can be done here, that 1 by cos x. 1 by cos, everybody knows, who knows trigonometric ratios, they know that 1 by cos is secant x. So plus c, this will be the answer, right? So this question is selected from American calculus book, which is taught at American high school, and American high school curriculum. So you can write in messages box also something. If you like the video, please hit the like button, subscribe the channel, and let us proceed in our discussion that we are integrating. Another, this actually is called indefinite integral because of the involvement of c here. You know that the c, why c arrives here is another discussion. We can discuss that as well, but let us proceed to the another problem, which is definite integral. Okay, so this time we will have we will have another question here, another question which will not have c in it. In the end, the answer will not have c, so it will be called definite integral. So definite integrals has upper limit and lower limit. So let us begin solving another problem. Here is, it is pi by 4 is lower limit, upper limit is pi by 2. Those who know trigonometry, those who know radian and degree conversion must be knowing that this is pi by 4 means 45 degree and pi by 2 means 90 degree. So from pi by 4 to pi by 2, These are the limits, and we have to integrate sine cube. It is not square, actually sine cube. Sine cube alpha, cos alpha. So how can it be done? This is another rule of integration will be followed here. So please hit the like button, subscribe the channel, write in the comment box anything you want to write. The topic of our discussion today is integration. Please hit the like button and subscribe button so that the growth of the channel increases. It's been 5 years uh, now. The publishing of the content has been on its way. So sine cube, how we handle another integration technique will be utilized here. See, it can be written as sine alpha whole cube can be written, right? And this is cos alpha d alpha. Do you know that this is function? This is sine, we call it function, and this is its derivative. Derivative of sine is cos. So if we call it f, this is f prime, means derivative. So those who know the derivative concept, they know that sine is function and cos is its derivative. What happens then? Then we have sine function with some power. In this case, we increase the function power of the function by 1, means it will be 3 plus 1 and divided by 3 plus 1, and now the integration is done and the limits will appear here, pi by 4 to pi by 2. So it can be written as, further it can be written as I hope my audience, you are enjoying this great mathematics content. And here is, we can write 1 by 4. This outside, because it has nothing to do with the limit. And this will be sine power 4 alpha, and the upper limit is pi by 2, lower limit is pi by 4. So now we evaluated the limit. 1 by 4. We put upper limit first. According to the rule of integration, upper limit means pi by 2 is to be substituted first, right? So minus lower limit, function with lower limit. So function is sine here, sine, right? Finally, we obtain the sine power 4 alpha, right? This is the function in which we put upper limit pi by 2 and minus the lower limit pi by 4. So we know values of these limits, values of these functions on these angles. So what are the values? Let's look. 1 by 4, sine pi by 2 is 1. So this will be 1 power 4, right? It can be written as sine pi by 2 whole power 4 minus, here sine pi by 2, sine pi by 4. Sine pi by 4 is 1 by square root 2. Sine 45 is 1 by square root 2 and its power 4. Here we keep simplifying this. 1 power 4 will be 1, and we know that 1 power 4 is 1 again. And here it can be converted into square, right? Square root 2, square will remove its root, it will become 2, and then again square will make it 4. So then it can be transformed into a form where we take LCM. LCM is 4, so 4 minus 1 is 3. 3 by 4, so finally it is 3 by 16. If I don't go direct here, so I need to write 1 by 4 and 3 by 4. Thank you so much, audience, that you join. You're enjoying this great mathematics concept called integration. So integration, few of my from the audience, I can call few because the channel audience base is not that big. It's only 1300 plus subscribers it has. So the growth is very limited. I personally myself think that whenever it will be approved by the creator, the Allah Almighty, it will get approval from him, it will have an exponential growth. So with that hope, I keep publishing the content. So here is the definite integral. We solved the definite integral. It has upper limit and lower limit. It is integrated sine cube alpha cos alpha, the product of the two functions. So we just have written it in the form sine alpha cube and cos alpha, considered one f with power 3 and the other f prime. So when such form happens, such form appears, we increase power of the function by 1 and divide by that value, and that becomes the integration. And after that, evaluation of the limit is done. Upper limit, we substitute upper limit in the function, that is pi by 2, and minus lower limit in the function, which is pi by 4. So finally we have evaluated, it is 3 by 16. Okay, the concept of the integration extends to another topic, another branch of mathematics, which is called differential equation. So one of the simplest differential equation is here. We can discuss that as well here. It is kind of an expanded discussion where we come across definite integral, indefinite integral, and the differential equation. So look at this particular differential equation where integration is involved, and let us discuss this. It is stated that, let me put the question before you. It is, here is the question, right? So can you read the statement of the question? Statement of the question is that solve the differential equation with the initial conditions that y of 0 is equal to 1. For your solution, find the value of y of e. Find the value of y of e. So let us begin solving this. How we just have to solve the differential equation first. Then we will be using initial conditions, y of 0 is equal to 1. And finally, we will evaluate y of e. So here is the differential equation, which is dy by dx is equal to y. So we have to integrate it. We have to solve this differential equation. This is a simple kind of differential equation. It is known as variable separable form. So variables can be separated, like we can consider it y multiplied by 1 and can do this. Bring y on left side and bring dx on right hand side. So 1 dx it will become. So we integrate both sides from here. Integrate both sides. Please hit the like button, hit the subscribe button, subscribe the channel, hit the like button, and what you can do is you can write something in the comment box. I will expect you to write something positive in the comment box. Thank you so much for joining, for listening, for appreciating the uh, presentation. So here, integrate both sides. 1 by y dy is equal to 1 dx. So how we do this? It is y can be considered as function and 1 its derivative. When denominator the function, numerator the derivative, then natural log of the function is y here, becomes the integration. So it can be integration of 1 by y is natural log of y is equal to integration of 1 under dx is x plus c. C is involved here. And using initial conditions, we will determine c. We will determine c here. So let us use initial conditions. What are initial conditions? Initial conditions are We can do this here, that y is equal to, it can be converted in the form exponential form. Log form converts into exponential form like this. Y is equal to e power x plus c. And if we name it c1, whether c or c1 or any other constant value, a symbol that represents constant. So c usually is written here. Y is equal to e power x, e power c1. So e power c1 can be considered, can be renamed as another constant. So we can uh, write it as e power x c, or y is equal to c e power x, right? Both are the same forms. Hit the like button. Thank you so much for joining, for watching, for appreciating the content. And here is initial conditions. If you look at initial conditions and the statement of the question, that initial condition is y of 0 is equal to 1. Can you see the initial condition? Y of 0 is equal to 1. So these initial conditions are used here. Y of 0, y of 0 is equal to 1 is given. It means x is 0, y is 1. So x is 0, right? Y is 1. If we use here that value, x is 0, y is 1. Y is 1. C at its place, e power x, x is 0. E power 0 is 1, so c is 1. It means if we write this with the value of c substituted, then it will be 1 times e power x, because c is 1. So y is equal to ex is the function, right? Now what he said us to find, finally, if you look at the statement of this differential equation based question, is finally he says find the value of y of e. Please hit the like button, audience. Thank you so much for joining the channel. Hit the like button and write in the comment box anything positive in your mind. Please write over there. Thank you so much for appreciating the content. And here it says us to find y of e. So y of e, we just have to substitute. Look, y of e means we have to put the value of x e. So this is the final form. E power e is the answer. So this channel has been publishing mathematical content for 5 years now, and thank you for appreciating, for joining. Uh, Here is another question, which is the integration based question. The topic of today's discussion is integration. So we are selecting questions to integrate. Another differential equation based question is there for us. So let us solve that. We can select another integration based question. The topic of today's discussion is integration. Integration is an important concept taught in Cambridge Assessment International A levels and in FSC and ICS and Pakistani curriculum. So we can learn how the integration techniques are applied, what the techniques are, and how are they applied to integrate functions. Actually, integration can calculate area under area of the irregular shapes. So obviously, finding area of the irregular shape is important. No definite formula applies on the irregular shapes, though the regular shape like triangle, rectangle, parallelogram, trapezium, uh, rhombus, kite, uh, polygons, all these shapes have definite formulas for their areas. Some irregular shapes appear which don't have a definite formula, which are of irregular shape. So their area can be calculated using integration. So integral calculus and the differential calculus is considered to be the a revolution in the and the entire journey of humanity towards mathematics. So, integral and differential calculus are the one of the big achievements done by Isaac Newton and the Leibniz. Gottfried Leibniz, these are the mathematicians independently working, one in England, one in Germany. These independently at the same time reach to the same conclusion, uh, mathematical research, and the new outcomes and the new invention that is called integral and the differential calculus. So both of them are credited as to invent the this very concept, and it is called a revolution in a mathematical journey of the humanity. And we are today discussing integration techniques, so how functions are integrated. Thank you so much for your interest in this mathematical content as well as towards our channel. So hit the like button and subscribe the channel. Appreciate our effort. Thank you so much for appreciating and supporting. So here are some more functions there to integrate. One of the simplest here is this. Look, one of the simplest, that how can you integrate 6x? Here the story begins actually, right? So we take 6 outside and integrate x. Integration of x. Integration here is a simple, this the simplest case of integration is that we consider, we can introduce to 1 here in multiplication, and product introduction of 1 in as a product means that we didn't have changed anything in it. So this is x, the function. This is its derivative. Derivative of x is 1, we know. This is function, this is derivative. So what we do here is we increase the power of the function. Means function of x is 1. We increase it by 1 and divide by that value. This becomes the integration. Plus c. So you can see that 6 x square by 2. So 2 will convert 6 into 3 by division. So 3x square plus c is the integration of that. So this is one of the simplest integration. This is how the story of the integration begins, right? If you want to learn integration, you can begin with it with me today and can learn the concept. Okay. The next we have is another simplest integration question is this one. Integrate 1 by 2x cube. So you know that this is different. This is an integral operator. This sign, you can see this sign. This is called integral operator. It applies on the variable part, not on the constant part. So 1 by 2 is constant part, acts as coefficient, is shifted out here. So, and it will be 1 by x cube. Yet I'm writing it like this. It can be written using basic mathematics fact. We can write it in as x power minus 3 dx. And then what we do is that x power minus 3. Look, again the same situation. X is the function. Its derivative 1 can be considered with it. So its derivative 1 is here. It means that its power can be increased. Integration is add 1 to the power and divide by that value. Plus c. These are all indefinite integral because of the involvement of c here, which is indefinite. So x power minus 2, pi minus 2 plus c. We know that these two in the denominator make 4, and the minus sign will appear with the coefficient. And x power minus 2 can appear in denominator as x power 2 plus c. This is another integration problem is solved. So I hope students that whosoever is watching this content will enjoy it, because anyone who can stay here for long has definitely mathematical uh, mindset and the interest area. His interest area is mathematics. So if you are that, you are one of the great person of the world and who likes mathematics the most. Here is another problem which can enable you to learn at least one rule of the integration is where you will be handling algebraic integration very well. So let us attempt that. It is x power 7. Once again, nearly the same situation is that x, x is the function and its derivative can be considered with it 1. 1 can be written as product anywhere and we write it here. So x power 7. So it means that x power, we add 1 to the power of x. So 7 plus 1 and divide by that plus c. So it is 1 by 8 can be written as x power 8 plus c. This is how the integration is done here. So this can make you learn one of the rule, right? One of the rule of integration you can learn by looking at it, that whenever x power x with some power appears, it means its derivative is 1 along with it can be considered, and we add 1 to the power of the of x and divide by that, that becomes the integration. So thank you so much, viewers, for joining, for enjoying. This is uh, integration concept is being discussed and has been discussed up till now. It's been 46 minutes in this session. So as the some more audience has joined, so I can keep this class going. So here we are integrating some. It is 7-degree polynomial function now. 7-degree polynomial function. So here is, I'm continuously speaking for 45 minutes, so wanted to end this session, but yet let let us keep continuing it. Here, integration x power 7 minus 6x plus 8. How will you integrate this? Actually, this integral operator, which you call integral operator, it applies separately on all these terms, on x power 7, on 6x, and on 8. So integration along with dx is one symbol. So these two make one symbol, okay? And between them comes the function which is to be integrated. So here is x power 7. X power 7, I rewrite it once again, okay? X power 7 dx minus I can bring 6 outside and x dx plus here 8 dx will be written like this. Only thing changes from the previous step to this step is we took 6 outside integration sign. Here x is the function and its derivative 1 is with it, right? X derivative 1 is with it, can be considered in multiplication, 1 can be considered anywhere in multiplication because it doesn't change the entire form. So x multiplied 1 can be considered. So x derivative 1 is here, x power 7. Integration is done just by adding 1 to the power of the x, or power of the function. When function with derivative is there, the function is power is increased by 1. 6 x power 1 is here, and its derivative 1 can be considered along with it. So its function power will be increased by 1 and divided by that value plus 8. Integration of 8 is 8x, right? So you can consider like this, that derivative of x is 1, integration is 1 is x. So 8 multiplied 1 can be written 1 integration is x, that appears here. After that we can look at it as 1 by 7. We can rewrite it as 1 by 8 x power 8 minus this is 6 by 2, right? X power 2 plus 8x, and whenever the integration sign and c comes into with the integrated function, 1 by 8 x power 8